Hello everyone. In this walkthrough, we'll see our setup for exporting the 2D facial texture swapping data from Maya and recreating the system inside Unreal Engine. Looking at Scribble's character rig in Maya, animators can change expressions by moving the controller over a texture atlas rig. The controller's translate X and Y values are directly linked to the translate frame attributes on place 2D texture nodes inside the Maya materials graph. Because we cannot export Maya's material nodes directly, we pipe these place 2D texture values into custom attributes on the data C00 joint. This allows us to bake and export the data as a standard joint animation. Inside Unreal Engine, we first import the mouth and eye textures. Crucial step here is to ensure that the texture group is set to UI, so that the alpha channels and transparency renders correctly. For the mouth and eyelids, we use a simple master material with a texture parameter. However, the eye pupil material we need to rebuild the Maya UV behavior. We use custom scalar parameters for repeat and offset UVS to drive pupil motion. We also create a mask using an alpha texture parameter of the eyelid, so the pupil never bleeds outside the eyes. To map our Maya data back to our textures, we create a custom struct containing translate frame U, translate frame V, and texture 2D index. We use this struct to generate data tables for our characters, linking the translate frame values from Maya directly to texture index numbers. Next, in our character blueprint, we initialize dynamic material instances for the face geometry in the construction script. In the event graph, we build custom events that reads the texture arrays and update the dynamic parameters. The animation blueprint acts as our main logic brain. Every frame, it reads the incoming joint animation curve data exported from Maya. We then look up those exact float values in our data table, finds the corresponding texture index, and passes it to our character blueprint. The pupil setup is a bit more complicated. To animate the pupil movement, we pull the raw repeat and offset curve values from the data C00 joint track and feed them directly into our material parameter nodes. With this system, we can create variants by swapping the skeletal mesh and updating the texture arrays and data tables.